drive sprocket, frontal idler wheel and 4 return rollers on either side. The Leopard's hull is fabricated from welded armored plate of varying thickness and geometry, while the turret is a complex all-cast component. Crew protection was enhanced with an automatic, manual trigger also available, fire suppression system and an NBC protection system, which produces an overpressure in the crew compartment and provides filtration of supplied air. The Leopard 1 can ford water obstacles, up to 1.20 deep, by wading without any prior preparation. Deeper obstacles, up to 2.25 m depth, can be negotiated by sealing the tank and fitting a foldable snorkel over the commander's cupola. 2 bilge pumps are provided to remove any water accumulated. Variants. Leopard 1A1. A West German Army Leopard 1A1A1 with additional spaced armor on the turret and gun mantlet. A Norwegian Army Leopard 1A1. After the last vehicle from the first 4 production series was delivered, the Bundeswehr initiated an upgrade program in 1970 to increase the combat effectiveness of its tanks. Known as the Leopard A1, later Leopard 1A1, after the introduction of the Leopard 2, these tanks received a new gun stabilization system from Cadillac Gauge, full stabilization in both elevation and traverse, as well as powered elevation from -9 degrees to +20 degrees, that allowed the tank to fire effectively on the move. The 1A1 added metal rubber skirts along the hull flanks to protect against heat warheads, and the gun barrel was wrapped in a jacket to reduce deviation from thermal loads. The track was changed to a D640, a double-pin type with detachable, rectangular rubber pads instead of the earlier double-pin dial D139E2 track with vulcanized treads. The rubber pads of the new tracks could be easily replaced with metal X-shaped grouses for movement on ice and snow. 20 grouses were provided for each tank and stored on brackets on the front hull of the glacis when not in use. A new snorkel was developed to load for underwater driving to a depth of 4 m after sealing the tank with special plugs. The driver's and commander's active infrared night vision periscopes were replaced with passive image intensification night sights. 7. Between 1975 and 1977, all of the tanks in the first 4 batches were brought to the Leopard 1A1A1 standard, and given additional turret armor developed by Blom and Voss, which consisted of rubber-lined steel plates bolted to the turret, including the rear turret basket, with shock-resistant spacers. The gunmantlet received a wedge-shaped armored cover made from welded steel plates, and the engine's air intake system was improved. Thus upgraded vehicles weighed 42.4 tons. An upgrade in the 1980s added a hybrid LLTV forward/passive IR aiming and observation system, which were being handed down from the Leopard 2 as they were themselves upgraded to thermal imagers. The PZB-200 low-light level television, LLTV, system with IRS-100 infrared scanner was developed by AEG Telefunken and mounted in a protective cage on the mantlet, above the main gun, creating the Leopard 1A1A2. The system combined an LLTV camera, which was a type of image intensification device producing a TV picture on the commander's and gunner's monitors, coupled with an IR scanner, sensitive to thermal differences in the 3 to 5 m wavelengths and based on a PBS detector, which would superimpose its processed IR image over the LLTV signal to improve target detection and identification. In the late 1980s, all digital SEM80/90 VHF radios were issued to the Bundeswehr and installed in various models of the Leopard 1. The Leopard 1A1A1 with these new radios received the Leopard 1A1A3 designator, and those vehicles with the LLTV/IR system and SEM80/90 radios would be known as the Leopard 1A1A4. Leopard 1A2. Cast turret Leopard 10201 with upgraded LLTV/IR night sights mounted inside of a protective cage to the right of the IR searchlight on the gun mantlet. The first 232 tanks of the 5th production batch were delivered as Leopard 102 between 1972 and 1974. The A2 included a heavier and better armored cast turret which was visually difficult to distinguish from the previous type. The most notable difference were the oval, as opposed to round, armored housings for the optics of the TEM range-finding sight. The Leopard 102 tanks were not subject to further armor upgrades as was the 101, but did receive improvements to their NBC protection system. 7. Throughout their service, these tanks would receive several other upgrades. The Leopard 10201 received AEG telefunctional forward/IR sights. The Leopard 10202 received digital radios, and the Leopard 10203 got both. Leopard 103. The next 110 vehicles in the 5th production batch were fitted with a new type of welded turret designed by Blom and Voss, which was equipped with spaced armor, consisting of 2 steel plates with a plastic filling between them, and a wedge-shaped gun mantlet, resulting in the Leopard 103. Although the level of armor protection was equivalent to the cast turrets of the prior two, the internal volume was increased by 1.5 m3 and the effective protection level was increased. The commander was given an improved TRP-2 independent observation periscope and both of the loader's fixed periscopes were replaced with a single unit with tilt and traverse adjustment. Most of the vehicles of this batch were allocated to the 10th and 12th Panzer divisions. Henceforth, all newly manufactured Leopard 1 tanks from Krauss-Maffei and Mark would use this welded turret, as casting large parts such as tank turrets was overly complex and the welder design carried greater upgrade potential. The Leopard 103 received a new welded turret which can be distinguished by its angular shape. Seen here is a vehicle of PZGren BTL301 in 1984. Subsequent upgrades were parallel to the 102 models. The Leopard 103A1 with improved night sights, Leopard 1A3A2 with the new radios, and the Leopard 103A3 with both. Leopard 104. Leopard 104 at the German Panzer Museum Munster. The vehicle I displayed with a deep folding snorkel, which would be used to draw in combustion air for the operation of engine while submerged in water. West German Leopard 104, far right, at the Canadian Army Trophy Gunnery Competition in 1979. The Leopard 104 formed the 6th batch of 250 vehicles, 215 manufactured by Krauss-Maffei and 35 from Mark A, starting delivery in 1974. The 104 was externally similar to the 103, but included a new integrated fire control system. This consisted of a stabilized PRR-12 independent sight for the commander, a new EMS-1201 stereoscopic rangefinder coupled to the gunner's primary sight, a fully stabilized main gun and full-fledged ballistic computer. Many of these systems were derived from the Leopard 2 program. While the EMS-1201 was still just an optical rangefinder, the desired laser rangefinder was still in development. It was used for target acquisition and linked to the ballistic computer, which would automatically produce a lead angle once the range was measured and several other ballistic inputs were computed. This solution reduced the time between target acquisition and engagement and increased first round hit probability. The PRR-12 sight improved the commander's efficiency, allowing him to acquire and relay targets to the gunner considerably faster in what can be considered the precursor to hunter-killer capability. The PRR-12 sight also had an integrated night channel, second-generation image intensifier, toggled with a switch, a considerable improvement over the prior TRP sights which had no night vision capabilities and had to be UN installed and exchanged for an infrared device. The PRR-12 was mounted in the turret roof forward of the commander's cupola and was protected by wire guards. The gunner's forward-looking observation periscope was deleted. The new equipment for the fire control system consumed additional space and the ammunition load was reduced to 55 rounds, of which 42 were stored in the hull-mounted magazine, while the remaining 13 rounds were in ready racks in the turret. The hull received only minor modifications involving the layout of the tow cables and storage rails for the winter grousers. Final deliveries of the Leopard 104 for the Bundeswehr took place in 1976 and would mark the conclusion of Leopard 1 production for Germany. Leopard 105. In 1980, a research program was undertaken to investigate further improvements to the Leopard 1, stipulating the need for a new fire control system, ballistic computer and thermal camera for effective night and all-weather capabilities to effectively fight against the more sophisticated Soviet T-64B, T-72B and T-80B series of tanks. A crucial part of the upgrade was the introduction of more effective ammunition. The Brazilian Army Leopard 105B, a tank including new APFS rounds. The decision was made to base the upgrade on earlier models which were no longer competitive. The resulting Leopard 105 was a retrofit of 1,225 Leopard 1A1A1 vehicles from Bundeswehr stocks. After trials, the Krupp Atlas electronic EMS-18 fire control system, which was developed from the EMS-15 used on the Leopard 2, was selected in December 1983. The large, box-like armored enclosure for the EMS-18 primary sight was mounted on top of the turret, in front of the commander's hatch, and contained a fully stabilized, both in azimuth and elevation, head mirror which was used for the daylight vision channel, 12 magnification and 5 degrees field of view, NDYAG laser rangefinder and a WBGX thermal imager from Carl Zeiss. The gunner would access both day and night channels from the primary sight via binocular eyepiece, in addition to his backup telescopic daytime sight, the TZF-1AM from previous models. The commander would receive imagery from the gunner's primary sight on his ocular by way of a light pipe. His station retained the panoramic periscope, improved model TRP-5AM, and vision blocks, with the TRP sight and forward-facing vision block raised to clear the EMS-18 sight housing. Both commander and gunner could control the turret traverse with hand controllers, but an override function was given to the commander. In a typical engagement scenario, the commander would identify the target and slew the turret to its azimuth, then hand the target over to the gunner. Using the primary sight, the gunner would aim at the target and laser it to obtain a range. Tracking would be initiated if the target was moving. The fire control computer would then take the manual, ammunition type, target speed obtained from the horizontal turret traverse rate, and automatic inputs, vehicle cant correction from a vertical sensor, atmospheric conditions, powder temperature, altitude, and continuously compute super elevation and lead solutions for the main armament. Control signals were transmitted to the turret and main gun drives to align the plotted aiming mark with the main gun bore axis, without disturbing the line of sight. Once these were coincident, the gunner could fire. The fire control computer contained ballistic information for up to 7 different ammunition types. Upgraded tanks initially made use of the existing Cadillac gauge stabilization system, but since 1988, all Leopard 105s were either built or retrofitted with a new SRK servo hydraulic turret and gun control system. The bulbous, horizontally opposed objective housings for the optical rangefinder were removed and their openings in the turret sealed with armor plates. 2 new types of high-performance kinetic energy APFS rounds were introduced for use in the Leopard 105, the DM-23, a variant of the Israeli M111 Hetz 6, and DM-33, Israeli M413 Hetz 7, rounds. One test vehicle was armed with the smoothbore 120mm main gun, and all of 5s are adapted to carry this weapon, but the concept did not proceed into production. The running gear on these vehicles was improved with strengthened torsion bars and shock absorber mounts. Lifting hooks were welded to the hulls of early production vehicles which lacked them, first and second batches, and the driver's station received high-pressure washers for high-observation periscopes, later installed in most Leopard 1s in German service. A three-tone camouflage was also applied to all tanks undergoing the conversion to a 5 standard. The first modified vehicle was delivered in December 1986, and the conversion process ran until 2001/2002, which coincided with a reduction of armored forces in the Bundeswehr, resulting in fewer Leopard 1A5 tanks delivered than were originally authorized. Most of the Leopard 1A5 tanks delivered to the Bundeswehr were assigned to formations of the former East Germany Army. 8. Leopard 1A5s, which received new SEM-80/90 VHF radios in the late 1980s, were designated Leopard 1A5A1. Since then, almost all users of the Leopard 1 have applied similar changes to their own vehicles, and in most ways the 1A5 can be considered the standard Leopard 1 today. Leopard 1A6. The Leopard 1A6 prototype was a single Leopard 1A1 test, modified with additional armor on the turret and equipped with a 120mm L/44 gun. The project was ended in 1987, as the Leopard 2 was in widespread service at this point, and the 1A5 offered a more reasonable upgrade path for a fraction of the cost. Modified and derivative vehicles. An armored engineering vehicle DAX, Badger, German Army Bergepanzer II of the Royal Netherlands Army with erected crane, a bridge layer Beaver, with armored vehicle launched bridge simultaneous to the production of the battle tanks. A number of engineering, bridging and recovery vehicles were developed, as well as a number of versions used in the anti-aircraft role. The most well-known Leopard variants are the bridge layer Beaver, Bergepanzer II armored recovery vehicle, Pioneer Panzer II DAX, Badger, armored engineer vehicle, and Leopard self-propelled anti-aircraft gun. The Warsaw Pact equivalent of the Leopard is the ZSU-23-4. Marconi Electronic Systems once offered conversions to the Marksman Spag for existing users of the Leopard 1. The Leopard 1 chassis would burst to carry the Marksman turret. The Canadian Army operates the Beaver armored vehicle launched bridge, Taurus ARV, and Badger AEV, all based on the Leopard 1. The United Kingdom's Royal Marines operate a vehicle known as Hippo Beach Armored Recovery Vehicle. The Hippo is a conversion of a Leopard 1A5 chassis by Alvis Moelv. The main alteration has been the replacement of the turret with a raised superstructure that resembles the wheelhouse of a boat. The original 830 HP, 634 kilowatts, diesel engine has been retained, but the gearing of transmission had been lowered, reducing the vehicle's road speed to 32 km per hour, 20 miles per hour, but increasing tractive effort to 250 kN, 56,000 lbf. Other modifications include the addition of working platforms, a nosing block, raised air intakes, and an auxiliary power unit. This raised the weight of the vehicle from 42.5 tons to 50 tons. The Hippo has a fording depth of 2.95 m, 10 feet, and can draw vehicles up to 50 tons weight or push off from the beach a 240-ton displacement landing craft. German company Flensburger Fahrzeugbau is the producer of a vehicle known as Weisend 1, a modernization of the Bergepanzer II. It comes in armored recovery vehicle, armored engineer vehicle, and mine clearing vehicle versions. The Weisend 1 is known to be operated by Denmark and Ukraine. 9. Gilded Leopard, Iber and Kiela. Almost as soon as the Leopard was introduced into service in 1965, Porsche was awarded a contract to study further improvements to the existing design, while awaiting deliveries of the MBT-70 in the mid-1970s. This original gilded Leopard, vergoldete Leopard, program expired in 1967 with no production order. In 1967, it had already become obvious that the MBT-70 would be a failure. The agreement between the US and the Federal Republic of Germany forbade any